Evening, everyone. So, welcome to the week 6th of this course, Digital Signal Processing and its application. So, today we will have a tutorial session on the lecture for the week 6, which is taught for this course in the NPTEL portal. And I'm recording this video, and this video will be uploaded on YouTube, and link will be shared in the NPTEL portal. So, if anyone wants to watch it later, they can watch using that link. So, we'll solve some of the questions. The first question is, what are the components required for implementing a rational system, LCCDE? LCCDE means linear coefficient differential equation system. So we have to find what are the components required in this. In what? Linear constant coefficient difference equation. So we can write for LCCDE, that is termed as linear constant coefficient differential equation. So such type of equations are having difference term and some constant coefficient. So like constant coefficient means like we can write like this: y of n plus a1, y of n minus 1 plus a2, y of n minus 2, and b naught x of n plus b1 x of n minus 1 plus b2 x of n minus 2. So here you can see the main part, that this is in the difference form and this is constant coefficient. So for such kind of system, how to represent this, like how for the implementation of this system, what and all are requirements. So there are lots of options, four options are given. So we'll check. So how to implement this? Like we can implement, like this is our input x of n. So x of n is given, the coefficient of x of n is b naught of n. So this will be b naught, and this is added with the difference term x of n minus 1. And what is the coefficient of x of n minus 1? B of 1. So again, here we will get b of 1. Now we have one more difference term, f x of n minus 2. And what is the coefficient of that? b2. So we will add here b2. And this 2 is added together with this. So these all are the coefficient of xn. Now same thing we will represent for yn. Now this is our output y of n. Now the first difference, that is y of n minus 1. What is the coefficient of this? That is a1. Now, the second difference term, and what is the coefficient here? Here we'll take minus a1 because when you take all these term on the same side, the negative sign will come. So we are representing this system that is linear, constant, coefficient, differential equation. So the first term, like the first difference term, y of n minus 1 have coefficient a1. So we have kept here minus a1. And the second y n minus 2 have coefficient a2. So here we will keep minus of a2. Negative sign is there just because when we take on the same side, it will become negative. So this is the representation of the uh, above system, which is linear constant coefficient differential equation. So now we will see what are the components used here. So one sample delay buffer. So yes, we are using the delay buffer, like these all are the delay buffer. So this is also delay buffer. So option A is correct. Now second is constant multiplier. So yes, these all are the constant multiplier. So we are using constant multiplier also. So option B is also correct. Two input adders. So are we using two input adders? Yes, this is the two input adders. And again, this is two input adder. Even this is also two input adder. So this is also correct. Constant adder. Are we using any constant adder? No. We are multiplying it with, then we are using the adder. So option D is not correct. So for question number 1, option A, B and C is the correct answer. So we'll move on to the next question now. So if xz is the z transform of x of n, so we can write the z transform of x of n is given as x of z. Then what is the z transform of the signal? Yn is equal to n square x of n. So we know that for n of x of n, it is the z, it is like the transform of minus z, d of dz, x of z. So the derivative of x of z and multiplication with minus z, that comes to n of x of n. Just give me a minute. So we can also prove this, better to prove, then we will solve this question. So like as we know, like when xn have z transform given as x of z, so n of x of n will have z transform given as this. So let's have a proof for this. Then we'll solve the question. So x of z, that is z transform of x of n, that can be written as summation of x of n z to the power of minus n. And here the value of n is from minus infinite to plus infinite. Now let's differentiate with respect to dz on both the sides, because here you can see dz is there, a differentiation of xz with respect to dz. So let's do that and see what we are getting. So d of x of z by d of z. So when we differentiate it, what we will get is x of n is not the term which is depending on z. So we can exclude that. And this become minus n into z to the power of minus n minus 1. Okay. So d of x of z by d of z is equal to summation of n of x of n z to the power of minus n divided by, like, z to the power of z inverse, and there will be minus sign. So minus z. We can write like this. So this is our limit. That not for let's not forget that. So once we get this, now we will take our minus z term this side. Because here you can see there is a minus z term. Okay. So we'll take minus z term on the left hand side. So after that, what we will get, minus z d of xz divided by, like, the derivative of xz with respect to z is given as summation n of xn z to the power of minus n. Okay. So basically this is simply the z transform of n of x of n. Okay. So this is proof. And on, like, the general form of this result is, so the generalized form is n to the power of k x of n will have the z transform as minus z to the power of k d by, like, derivative of order k of x of z. So this is the general form. So here in this question it is yn is equal to n square of xn. So here k is equal to 2. So for n square x of n, the z transform what we will get is minus z to the power of 2 del square by del z x of z. So minus z squared is z squared ds double derivative of xz with respect to dz. So which option is correct? We can write it as, or we can solve in different way. We'll just solve, like, without the generalized equation. We'll solve it and then we will see the generalized equation. So here in this, like, we know in that above form, we'll write this equation at the end after solving this question. Like above, what we have proved that minus z xz, this is the z transform of n of xn. Okay. So now let's suppose this term is our w of n. the whole term. So W of n is equal to n of x of n. So W of z is equal to minus z derivative of xz with respect to z. Now our y of n, like in this question, is given as n squared xn. Okay, so n squared xn. So what will be this term will become? This term will become n of w of n. So now when there is n of w of n, so what will be the z transform of this? N of w of n will have z transform as minus z del by del z w of z. Okay, so now we will substitute this w of z here. Okay, so what we will get as an answer, like y of z, like this is our y of z. So y of z is equal to minus z derivative of wz. Wz is minus z d by dz x of z. So this we can write as minus z minus z double derivative of xz, and next time it will be 1, so it will be minus of single derivative of x of z. Okay, just take this term inside this bracket, so you will get this. So our y of z will become minus z squared double derivative of xz minus z x dash of z. Oh, sorry, it's minus, it will become plus and plus. Both the term will become plus because minus into minus will be plus. So which option is correct? So z squared x double dash z plus z into, so here there will be one x derivative, like derivative of xz. Option B is correct. So we can correct this option here. It is x derivative of x of z. So now we'll move on to the next question. So given an input to a rational system, xn is equal to del n plus del of n minus 1. So this is the impulse function. The observed output was y of n is equal to u of n minus u of n minus 4. So we have to find the system function. So it is a rational function, then it is like defined as h of z, like x of z into h of z is equal to y of z. For rational system, we can define it like this. So the system function h of z will become y of z divided by x of z. Now, this is our x of n is given. What it is given? That is equal to impulse function and the summation of shifted impulse function. So our x of z is equal to summation of x and z to the power of minus n. So this will become 1 plus, and this will become z inverse. Okay, because we know that del n have z transform as 1, and del n minus 1 will have z transform of z to the power of minus 1. So this is our x of z. Now y of z we can write using the definition of z transform is y of n into z to the power of minus n. So this will become See, y of n, what is the value? Is equal to u of n minus u of n minus 4. So what is u of n? So this is our u of n. Now what is u of n minus 4? This will be shifted at 4. So when you draw u of n minus 4, you will get 1, 2, 3, 4 unit, and here you will get the value as 1. So on. Now when you do u of n, this is our u of n minus 4. So u of n minus of u of n minus 4, what it will be? It will be like all the terms after this term will get subtracted, okay? Because here also for 4 it is 1, for 5 it is 1. So all these terms after 4 will get subtracted, and we will get the value as at 0, at 1, at 2, and at 3. Okay? So this is our y of n, that is equal to u of n minus u of n minus 4. So this will become 1 into z to the power of minus n, and value of n is from 0 to 3. So our hz, that is equal to y of z divided by x of z is equal to summation n is equal to 0 to 3 z to the power of minus n. What is of x of z? 1 plus z inverse. So this we can write 1 plus z minus 1 plus z minus 2 plus z minus 3, and is from 0 to 3, and our x of z is 1 plus z inverse. So which option is correct in this given question? Option A is the correct answer for this question. So we'll see now next question. So we have to find the Z transform of the signal xn. Xn is given as sine of kn into u of n, and here k is a positive constant. So for this type of question, what we will do, we will break sine k of n in terms of e to the power of in the exponential term. So before that, we will see what is the Z transform of exponential. Let's suppose xa of n is equal to e to the power of minus an un. So what is xa of z? That is equal to, like we can expand also, xa of n z minus n. N is equal to minus infinite to plus infinite. So this will become, well, it is unit, it is xa of n is multiplied with unit step function. So here the limit will change from 0 to infinite. Okay, and xa of n is e to the power of minus a n z to the power of minus n. So we can write this as e raised to the power of minus a into z to the power of minus 1 into the power of n. So this is a GP series, and the summation x of z is equal to 1 by 1 minus z inverse e to the power of minus a. So this will be the z transform. When we do like when we take multiply with z in denominator and numerator, we will get z by z minus e to the power of minus a. Okay. So similarly, what we will do now, we will break the sinusoidal signal sine kn un in the exponential form. So we can write as x of n is equal to 1 by 2j e to the power of j k n minus e to the power of minus j k n multiplied with unit step function. So here this term will lead to 2j sine of kn. When you expand this, you will get this. Now this 2j and 2j will get cancelled, and then you will get sine kn. So our main intention was to break this sinusoidal function into exponential. And we know for exponential the z transform. So x of n. Now we have to take the z transform of this. So just give me a second. I got a call. So okay, so we'll take the separately the z transform of both the term. Like this is our first term and this is our second term. So xz is equal to 1 by 2j. Now what is the z transform of e to the power of minus a n? This. So similarly, e to the power of j k n, what will z transform? It will be z divided by z minus e to the power of like if minus a n, then we take the constant like the term multiplied with n. So here it will be e to the power of jk minus z by z minus e to the power of minus jk. So this is our x of z will be like 1 by 2j. This will become z square uh, minus z e to the power jk. So basically when you do you can simplify this equation, multiply this and simplify. The correct answer for this question is z sine k divided by z square minus 2z cos k plus 1. Can be the correct answer. You can just simplify this, you will get z sine k divided by z square minus 2z cos k plus 1. So now we'll move on to the next question. Again, this question is on linear constant coefficient differential equations. So here you can see these all are the uh, constant term and this is the difference equation. So this equation is given as y of n minus 0.7 y of n minus 1 plus 0.1 y of n minus 2. This is equal to 2 of x of n minus x of n minus 2. So now for the approximate expression for the output yn, given that n is greater than or equal to 0 and given that yn is equal to 0 for n is less than 0. For the input xn is equal to 4 to the power of n un. So the input is given, we have to find the approximate output equation. And yn is equal to 0 for n is less than 0. Okay. So for this question, what we will do, h of z we know that is equal to y of z divided by x of z. So here we can write y of z minus 0.7 z inverse y of z plus 0.1 z, z to the power of minus 2 y of z is equal to 2x of z minus z to the power of minus 2 x of z. So now let's take y of z common. It will become 1 minus 0.7 z inverse plus 0.1 z minus 2 is equal to x of z 2 minus z to the power of minus 2. So what is our h of z? That is equal to y of z divided by x of z. So this will become 2 minus z to the power of minus 2 divided by 1 minus 0.7 z inverse plus 0.1 z to the power of minus 2. So this is our system function. Now we can write this as this term. Like we can do like this, 2 minus 1 by z square divided by 1 minus 0.7 by z plus 0.1 by z square. Now multiply with z square on numerator and denominator, we will get 2z square minus 1 divided by z square minus 0.7z plus 0.1. So this we can write as 2z square minus 1 divided by z minus 0.5 z minus 0.2. So here the poles are, these all are the equation for the poles. So poles are at 0.5 and 0.2 and the input given is xn. In this question this is given as 4 to the power of n into u of n. So xz is equal to z by z minus 4. Okay. So when you do y of n, we will get from the above equation. Like from here we can see that input pole are at z is equal to 4 and output pole are at z is equal to 0.5 comma 0.2 and also it will be at 0.4 because 4 because it is taking the input also. So basically we know that yz is equal to hz into xz. So all the poles of hz and all the poles of xz will be the poles for the output. So what is the value of y of n? Y of n will be a 4 to the power of n plus b 0.5 to the power of n plus c 0.2 to the power of n. All the poles we took there. So now just substitute this value of y in this equation. Okay. So finally we will get a little lengthy question. A 4 to the power, or we can write first here the equation y of n minus 0.7 y of n minus 1 plus 0.1 y of n minus 2, that is equal to 2x of n minus x of n minus 2. So we can substitute the value of y of n, that is a 4 to the power of n plus b 0.5 to the power of n. Now minus 0.7 into y of n minus 1. So here we will get a 4 to the power of n minus 1 plus b 0.5 to the power of n minus 1 plus c 0.2 to the power of n minus 1. Again plus 0.1 into a to the power of 4, a into 4 to the power of n minus 2, because it is 0.1 into y of n minus 2 plus b 0.5 to the power of n minus 2 plus c 0.2 to the power of n minus 2. So this is our left hand side, and right hand side is x 2 into x of n. So 2 into 4 to the power of n minus x of n minus 2, 4 to the power of n minus 2. So now when you find when you now simplify these equations, like how will you simplify? You will take the coefficient of n minus 1, n minus 2 separately, and the constant term separately. Then what you will get? You will get that a into 4 square minus 0.7 into like 0.7 into a into 4. Like when you are substituting for n is equal to 2, and plus 0.1 into a. This value will be equal to 2 into 4 square minus 4 to the power 0, that is 1. So we will get value of a is equal to around 32 minus 1, 31 divided by 16 minus 0.28 for 2.8 plus 0.1, equal to 13.3. Now substituting n is equal to 0 in the difference equation, we will get y of 0 minus 0.7 y of minus 1 plus 0.1 y of minus 2. This equation was given in the question, that is equal to 2 of x of 0 minus x of minus 2. Okay. So since y of minus 1 is equal to y of minus 2, this is also given in the question, this is 0. Okay. So it implies that we will get y of 0 is equal to 2 into x of 0. So that is 2 into 1. That is equal to 2. So now 2.33 value of a plus b plus c, this value is equal to 2. And also when you substitute n is equal to 1, then you will get y of 1 is equal to 9.4. So again we can write 0.5b plus 0.2c plus 9.32 is equal to 9.4. So similarly we will get the value of B as 0.477 and C is equal to 0.807. So what is our y of n? That was 0.477, 0.5 to the power of n minus 0.807, 0.2 to the power of n plus a 2.33, 4 to the power of n, u of n. So the correct answer for this question is option number C. Okay, this is our A, this is our B, and this is our, sorry, this is our B and this is our C. The system is said to be minimum phase if the system and its inverse are causal and the stable. Identify which of the following can be minimum phase system. So minimum phase system means if the system and its inverse are causal and stable. Okay. So here you can see in option number B, the poles of the system are 0, 1 by 4, and zeros are 1 by 2 and 1 by 3. So all the poles and the inverse of the poles lie within the unit circle, hence the system can be causal and stable. Option B is correct here. Which of the following statement is incorrect? So all poles are lying on the unit circle, system may be causal. This is wrong. It should lie inside the unit circle. ROC includes unit circle. The system must be stable. Wrong. The highest magnitude of the pole is half. The system can be causal and stable. This is also wrong. Option D, a causal system can have an ROC which is in the shape of annulus. So if the ROC is annulus, it is not possible that ROC includes Z like tending to infinite. Hence the system cannot be causal. So sorry. So option D is the incorrect option. Actually, these three options are correct. Like all poles are lying on the unit circle, then system may be causal. ROC includes unit circle, the system is stable, and highest magnitude of pole is half, so the system can be causal and stable, as we have seen just now. In this question, actually, it is asking which of the statement is incorrect. So, given the following response, Hn is equal to, this is the response of Hn. Determine which of the statements are true. So, this is a multi-correct. So, for n is less than 0, the system is this system is clearly causal because for n is less than 0, like for n is less than 0, h of n is equal to 0 because of this unit impulse function. So Here also this term is at impulse at n is equal to 10 and this is for n is equal to 2. So for n is less than 0, this value like Hn is equal to 0. So the stability of the system is decided by the exponent term of the polynomial exponential term, which is alpha to the power of n. And hence for the system to be stable, we require alpha that is less than 1. So for system to be stable, we require like the magnitude of alpha should be less than 1. So option C is the correct answer for this question. A system has system function as follows: z minus 1 into z minus 1 by 3 divided by z minus 1 by 2 into z minus 3. The reason of convergence is not known. Which of these can be true for the system? So if hz converges on z is equal to 1, then it is stable. And if it converges on the counter z tends to infinite, then it is causal. So option A is correct. The system is causal but not stable. Therefore, if the ROC is if ROC is mod z less than half, then system is neither causal nor stable. So this option is correct. The first one, it is stable and causal. Now if ROC is greater than half and less than 3, in that case the system is stable but not causal. So system is stable but not causal. The option C is correct in this case. Now if the ROC is mod z that is greater than 3, the system is causal but not stable. So option B is correct. So option B, C, D is correct. Okay. So for different type of ROC, here we will write as we know that if h of z converges on mod of z is equal to 1, then it is stable. And if converges on z tends to infinite, then it is causal. So if ROC is less than half, then system is neither causal nor stable. If it is half to 3, then it is stable because z is equal to 1 comes, but not causal. And if z is greater than 3, then it is causal system. So option B, C, D is the correct answer for this question. So let Hz be defined in the previous question. Which of the following system is cascaded with Hz can be both causal and stable? So now we have to cascade Hz and Gz. So our Fz is equal to Gz into H of Z. So the system causality and stability is independent of the and zeros of the system function. The only option for which the resultant function converges on both of the counters z is equal to 1 and z tends to infinite is the here. Which option is there? Like we have to find for both causal and stable. What is the case? Like sorry, here if f of z converges on mod of z is equal to 1, then it is stable. If if f of z converges on z tends to infinite, then it is causal. So in this case, when we do fz gz into hz, our hz is from the previous question z minus 1 z minus 1 by 3 divided by z minus half z minus 3. So when you multiply, then z minus 3 will go away in option C, and z minus 1 by 3 and this will go away. So the only ROC will be for option C, mod of z greater than 5. Okay, because here our f of z will be z minus 1 divided by z minus 4 by 5 and z minus half. So ROC will be, sorry, it is 4 by 5. So in that case, it is both causal and stable because the ROC contains z is equal to 1 and z is equal to infinite. Okay. So we will stop the lecture today here only, and we'll meet in the next class on the Tuesday. Sorry, on Monday again, 7 to 9. Thank you everyone for attending today's lecture.